Okay friends, so now actually let's get started on abstract classes. Again we'll use the same example. Okay, over here this keyword abstract is very important. Now why it is important is reason is this. Let me go back to my clips. Yeah, over here. Abstract. You know this class actually contains some method, actually two methods, which are not defined, they are just declared. So in a sense the class is incomplete, if you may say so. So when we want this kind of class which has some incomplete methods, of course members cannot be incomplete, attributes cannot be incomplete, but when methods are incomplete you may essentially want to make that class abstract, because otherwise Java will throw error. Let's see. If I remove the abstract keyword from here and from here also, you see I get these errors over here. What do they say? This methods require a body instead of a semicolon, right? So I put the abstracts back. So because of this reason Java will throw an error, but abstract class is essentially a template kind of thing. Okay, so all abstract classes need to have some subclass which is non-abstract, and that subclass will implement these methods which are incomplete in the superclass. Okay, even if these methods are not used in the classes, they must be implemented. Now this is a directive. It is not compulsory, but it is a directive that you usually do that, right? So I also put these methods to be abstract because they are incomplete in themselves also. So now this is also another directive which you must remember, that abstract method can only be contained in an abstract class. If I have not put class to be abstract, these abstract methods cannot be the part of this class. Simple. Okay, let me reiterate it. That let me reiterate it. That these methods are just declared and they are not defined, and hence I put the word abstract in the method definition to just indicate that these methods are incomplete. What do they do is not defined. The operations within the method or the statements within the method are not written, and hence these methods are just abstract. Abstract in literary sense, abstract. It is abstract, right? So there are two such abstract methods that I use. Now it is a Java directive, or it's a Java compulsion, that abstract methods can never be the part of non-abstract class, because if methods are abstract, they're incomplete, so is the class in which these methods reside, and hence the class would also be abstract, as I have done over here, right? Okay, and I'll go to my circle. Now it extends my geometric object class, right? Now you see I have to write the methods get area over here. What if I don't write this method? I get an error. The circle type must implement the inherited abstract methods of geometric object dot get area. That means the circle class inherits the geometric object class, but it doesn't implement the abstract method. It has to abstract. Or if I don't want to implement this method, I want to make this class also to be abstract, like this, and then I should be fine. Okay, so there are two options: either you implement those methods or you declare the subclass to be abstract again. So hence I implement these methods get area and get perimeter. Okay, and that is the reason I put this class to be non-abstract class. Okay, right. Now similarly, let me look at the rectangle class over here. Again, it extends the geometric object, and hence it has to implement the get area and get perimeter method by any means. It must do it, right? And which I do it over here and here. Okay. Okay. So what happens? I go back to my geometric object class, and what happens if I don't have these abstract methods? Can I still call the class to be abstract? Yes, why not? It's my choice. The class is not incomplete, but even if then I want to call my class to be incomplete, it's my pick. I can do that. Usually you don't do that, but there may be some scenarios where you may want to do this. So a class can be abstract even if it does not contain any abstract methods. Okay, one small thing which you should remember. Okay, so now we have this all combination of inheritance, abstract classes, subclass, superclass, and everything. But what do we do with this? If you remember, we did use this same classes for casting to understand the concept of casting in the previous lecture. So maybe we should write some program this time to see the use of this abstract classes and just see how they work. Let's go ahead and do that. Okay, and I will show you how various of the concepts associated with abstract class can also be understood by this example. And let's see the example in the next part of this lecture.